So we're going to continue taking a look at our constant acceleration model summary sheet. So in a previous video, we took a look at all of our different quantities and symbols. Next, we're going to look at our mathematical models and equations. So displacement is delta x, and it is our final position minus our initial position. Okay, so remember, displacement tells us where did we end up compared to where did we start, regardless of how we got there. Okay, average velocity, we can write two different ways. So our average velocity equation that we learned first, it just looks like this. Average velocity is our total displacement over our total time. Okay, if we wanted to sub in instead of displacement, actually put in x minus x naught and rearrange it, this would look a lot like our constant velocity model equation, which was x equals v average times t plus x naught. So these are both the same equation, just written slightly differently. I just wanted to point this out, that this kind of equation here where we saw with constant velocity, we can also use that for average velocity as long as we've got our constant acceleration. But do not use this equation if our velocity is changing, if we have acceleration, unless you are interested in the actual average velocity. So just a caution there. Next, we're going to look at our three different equations that we use for constant acceleration motion. Okay, so we got v equals v naught plus at. Okay, so our final velocity equals our initial velocity plus acceleration times time. Okay, then with this equation, we're going to use this one if we know or want to find these values, and perhaps we don't know anything about position or displacement, because you'll notice x does not show up in this one at all. Our next equation, x equals x naught plus v naught t plus 1/2 at squared. Okay, this is the equation that we want to use if we don't know anything about our final velocity and we're not looking for final velocity. So you'll see final velocity does not show up in this one at all. And then our last one is v squared equals v naught squared plus 2a. You can write this x minus x naught. Okay, and so that's the equation that you want to use if you don't know anything about time and you're not interested in time. Another way to write this guy out is v squared equals v naught squared plus 2a delta x. Okay, so maybe I don't want to keep x minus x naught separate. Maybe you want to make those delta x. You can do that. Okay, same idea with this equation here. Maybe I don't know my initial or final position, but I know my displacement, or I want to find displacement. You could still solve this way, or we could move x naught over to the left, subtract from both sides, and we would get delta x equals v naught t plus 1/2 at squared. So the equations I wrote in purple are just variations. They mean the same thing. It's just a slightly different way of writing them. Okay, and then the last thing that we have on this page is just talking about a descriptive model. If we're trying to describe in words and sentences, so some things to keep in mind when describing motion using graphs is to talk about what is the starting position, talk about the type of motion. So instead of just saying accelerating or the object accelerates, be specific. Is it speeding up or is it slowing down? Okay, do we have a constant velocity or is the object at rest? Okay, when you're referring to velocity, maybe talk about the actual or relative velocity. Okay, so if we're moving faster or slower, what the actual numerical value is. Also include the direction. Are we moving in the positive direction or negative? What's the time interval for the particular motion we're looking at? Where do we end up at each time interval? And do we have any direction changes in the middle? Okay, some things that you never want to say. Never say the motion is constant and leave it at that. You always have to indicate what is constant about the motion, if anything, okay? Because all of these things mean very different motion. So is it constant velocity or constant speed? Okay, remember, something can have a constant speed but change direction, then it's not a constant velocity. We have a constant acceleration. Okay, so we can have a constant velocity and no acceleration. Okay, or we can have a constant acceleration and a changing velocity. If the position is constant, just say the object is at rest. Saying constant position, while technically correct, is just kind of awkward, and most people don't use that. Okay, if you say constant position, I'll know what you mean. But again, don't just say the motion is constant. Explain what exactly is constant.